Okay, this next one is another polynomial function f of x, and it gives it to us there in factored form. And so this is convenient, so we don't have to actually factor it. We can pull plenty of information off of it, like the x and the y intercepts. We could even make a statement about the end behavior. And we will probably need the graph. Well, we definitely will need the graph to help us answer these other questions about when is the function positive, meaning that when is it greater than 0, and when is it negative, less than 0. So let's get into this one. The X intercepts here, this, if you did a zero product property, or if you were to set this equal to 0 and did the zero product property, that first factor suggests that there's an X intercept at 2. The second factor there, here, this suggests an X intercept at negative 1/2. It's actually an X intercept at negative 1/2 with multiplicity of 2 because of that 2. So that if you would have said use zero product property, negative 1/2 would be an answer twice. And then this last factor, it gives us a 0 at 1. So what we can do with that, well, we could transfer that information to the graph, and we will in a second. But we also can find the y-intercept. That's just going to be y is equal to 2 minus 0 times 0 plus 1 quantity squared times 0 minus 1. So this would be 2 times 1 times negative 1. So it's going to be negative 2. So the y-intercept here then is at negative 2. So we could transfer all this over to the graph on the left, and I'm going to do that, and I'm going to use green dots for it. So the graph is on the right. So the x-intercepts are at 2, 1, and then negative 1/2. So like right there. And that negative 1/2 x-intercept gives it kind of bounces off the x-axis there. It doesn't go through it. Then also there's that y-intercept at negative 2. So we got a point right there. Okay, now we also know, because if we were to multiply all this whole thing together, we would have a polynomial of degree 1, 2, 3, 4. So this is a 4th degree polynomial. Oops, that's not how you spell polynomial. And it is going to be a negative leading coefficient because of that negative x right there. So it's negative. That means if we wanted to do a really terrible sketch of what this would look like, it would be down, it would do like a W thing. Oops, down, do like a W thing and go down. So we can already write the end behavior of this. We know that the limit of this function f of x, as x is getting really, really big positive, is going to be really big negative. So as I'm going that way, x is just going to keep going down that way. As x goes to the right, y is just going to keep going down forever that way. And in the same way, the limit of f of x as x approaches really big negative values, or negative infinity, is also going to be negative infinity. It's going to go down like that forever as you're going this way in x. And that's it. You can write these in. There's an alternative way to write this. You can say that the limit of f of x as x approaches infinity does not exist, dne, because technically the limit can't equal infinity. Nothing can equal infinity. And you would do the same thing for x of as x approaches negative infinity, but either way is totally fine. Okay, so now we're going to need the calculator to sort of get some extra, extra information about this. So, like, specifically, the information we want from the calculator is like, where does this little bottom part end up, and where does this little top W part end up? So, the calculator will let us do that. So we're going to fire up the calculator. Turn it on. I have the wrong function there, so let me type that function in really quick. That's 2 minus x times 2x plus 1 squared, and then x minus 1. Alright, so if we graph that, there's your polynomial. So what we want to find here are this little bottom, the coordinates of that little bottom point, local minimum, and the coordinates of that local maximum. So let's find the minimum first. Second, calculate, go down to minimum, and this is to the left of it, this is to the right of it, and that's the middle. So that point right there, there's going to be a point on this graph at 0.387, negative 3.1. So like somewhere in this area. And then there's going to be, and this coordinate, let me write that in red. And this coordinate would be negative 3. Nope, that is not negative 3. It is 0.387, and oh, I don't know what's going on now, and negative 3.11. Okay, then we also want to find that maximum, so we're going to do the same thing again. Second calc, go find the maximum, and we'll go over, this is to the left of the maximum, this is to the right, and if we search right there, we should find it, and that is at 1.6 and 4.23. So 1.6, 4.23, somewhere in this area here, somewhere in that area right there. I don't know where it went. There it is. Okay, and in red, this will be 1.6 and 4.24, whatever. Okay. Oh man, this is really protesting. Okay, so then if we wanted to graph this, again, we know it's going to do this kind of behavior, so it's going to do this. So we'll start down at the bottom, and it's going to come up, and it's going to bounce off the x-axis right there. It's going to cross the y-axis right there. That has a minimum, so it's going to hit there. It's going to go through that x-intercept, hit that maximum, through that x-intercept, and then it's down the rest of the way. So that would be the graph of that function, but we still have to come back and answer these other questions. When is f of x greater than 0? So that's talking about when is it positive, and it's positive. Uh-oh. What happened there? I just deleted my whole graph. Okay, let me sketch that in again, I guess. Oh, I used eraser, not highlighter, that's why. So I was going to do this somewhere up there. Okay, so I was going to do that. We want to know when, what's this, like, what is this interval here? That's all, when f of x is positive. So f of x is that's positive from, oops, from, that would be from 1 to 2, and that's it. And then when is f of x negative? Well, that's just going to be all the rest of it. So from negative infinity up to negative 1/2, union negative 1/2, because we have to skip that 0, because it's neither positive nor negative there. I don't know why this keeps going forward. It's really annoying me now. Then up until that 1, that x-intercept, and then finally again from the 2, to positive infinity, and then that's it. Then we're done right there.